All right, guys, last one on standard normal distributions. We're just going to go over to the last page, which is 24 to 30. I really suggest you guys try and do these on your own first, and then come back here and check your answers. But if you're still having a hard time with this, while I'm going to go through them, if you have any questions, feel free to send them over and ask. So make sure it's recording. It is, okay. So yeah, have your normal distribution curve ready. Says on a standardized test, Phyllis scored 84, which is exactly 1 standard deviation above the mean. If the standard deviation for the test is 6, what was the mean score for the test? So Phyllis scored an 84 and was exactly 1 standard deviation above the mean. So Phyllis scored an 84 and was exactly 1 standard deviation above the mean. And it said that the standard deviation was 6. So, well, it should be 1 standard deviation down from this. So we're going to subtract 6. 84 minus 6 is going to be 78. Okay. So again, so the mean score is going to be 78. Okay. She was 1 standard deviation above, then kind of looking down 1. Says the heights of a group of girls are normally distributed with a mean of 66 inches. 95% of the heights of these girls are between 63 and 69 inches. What's the standard deviation? Okay, so again, that 95% number, they rounded it, which by the way is why we skipped one of the other problems, because they were using a little bit different numbers. But again, what is that 95.4%? So that's going to be 2 standard deviations in the other direction, right? So that's 2 standard deviations, 1, 2, 3, and 4. Okay, and I said the mean height is 66 inches, and from 63 to 69. So if this is 66 inches, and this is 63 and 69, essentially we want to know, hey, what's halfway between 66 and 69? Well, there's 3 numbers, right, between 66 and 69. So what's half of 3? Be 1.5. So again, 1.5 plus 66 is going to be 67.5, right? If you were a little bit lost, you can always go ahead and just take the average, okay, and say, hey, what's 63 plus 66 divided by 2, and that's going to give you, oops, I did it again, did that yesterday. Okay, it's going to be 64.5, okay? So again, if you want to find the numbers, that's fine, but they didn't ask for the actual numbers. They want to know, hey, what's the standard deviation? And what does that mean is that how do I get from here, from each of these numbers to next, okay? And what is it that's adding 1.5? Adding 1.5, adding 1.5, okay? So when they said, hey, what's the standard deviation for this group? Okay, we're going to say standard deviation is equal to 1.5 inches. Okay. A set of scores with a normal distribution has a mean of 50 and a standard deviation of 7. Approximately what percent of these scores fall from 36 to 64? So let's go 50 and a standard deviation of 70. So again, your mean is going to be 50 and your standard deviation is 70. So we're adding 7. So it's going to be 57 will be 1 standard deviation. 64 will be 2 standard deviations. And what is it? 71 will be 3. And then go down the other way. 43, 36, 29. Okay. And they asked approximately what percent of scores falls in the range of 36 to 64. Well, that's 2 standard deviations in either direction, right? 36, 64. So what percentage is that? 95.4. Okay, they've been rounded 95. That's fine. 95.4%. Okay. On a standardized test for the normal distribution, the mean was 64.3 and the standard deviation is 5.4. So 64.3. again, what do we got? We got 64.3, and they told us it was 5.4. 5.4. Okay. So again, 64.3 plus 5.4 is going to be 69.7. Plus another 5.4, 75.1. And again, another 5.4 will be 80.5, okay? And again, going down the other way, and subtract, we say 64.3 minus 5.4, 58.9, minus another 5.4, 53.5. And again, one more time, just to be sure, minus another 5.4, 48.1. Okay, so what do they want to know? What percent of scores fall between 61.6 and 75.1? Did I do the wrong numbers? 64.3. And a standard deviation of 5.4. Do that right. Okay, so I figured out what they did. They actually wanted a half standard deviation, which we're not quite up to yet. We don't actually have to know that for your level. You do that when you guys get to stats in college. But we're just going to modify this question. It actually was, they want to know from here to here. And all you need was a different table. So we're just going to modify that question. We'll say from 58.9. So they wanted to have standard. Sorry about that, guys. So we're going to say from 58. Let's say from 58.9. Okay. So again, what do we got here? If we want to know that, we need 34.1, another 34.1, and 13.6. So 34.1 plus another 34.1 plus a 13.6. Again, just add them all together. 34.1, sorry. Plus 34.1 plus 13. Oh no. 15.6. Okay, you're going to get 81.8. 81.8%. Okay. Again, just to note, you guys, you can do half standard deviations and things like that, but it's a little above what we really need to be able to do and at your level. If you guys really want to do it, we can take a few days and we can go over how to do that. It says the mean of a normally distributed set of data is 52 with a standard deviation of 4. Approximately 95% of all these cases will lie between which two measures. So again, they want two standard deviations in either way, right? So they want 95%, they want two standard deviations in either way, okay? So again, let's kind of move away from that for a second. So let's 52 with a standard deviation of 4, right? So again, if we went one standard deviation, that would be 56. If we went two standard deviations, that would be 60. If we went down one, we have 48. And down another one, that would be 44. So between which measures? Well, again, between 44 and 60. Okay? Good. What says battery lifetime is normally distributed for large samples. The mean lifetime is 500 days, but with a standard deviation of 61. So again, 500 days with a standard deviation of 61. And they wanted to know what percentage would be out here. Okay. So they wanted to know, hey, approximately what percent of batteries have a life longer than 561 days? Okay, so again, they want to know this out here. We got 50, we got 34.1, right? So we're going to take this whole thing, and say 100% was the whole thing. So we're going to take 100% minus what percent we got here, and that'll give us the remainder over there. So we've got 100 minus the 50% minus the 34.1%. 100 minus 50 minus 34.1. And what is that going to give you? 15.9%. Okay. Again, the more you work with these numbers, the more they will just become kind of, regular things like multiplication tables, things that you just know. Okay. So the test was given to 120 students, and the scores approximated a normal distribution. If the mean score was 72 with a standard deviation of 7, approximately what percent of the scores were 65 and higher? Well, we're going to take this a step further because they told us how many students. So not only are we going to get the percent, we're also going to tell you how many of those students, okay? So again, if the mean was 72 and they want 65 or higher, the mean was 72 and they wanted, well, the standard deviation was 7, so 65 is going to be right here. So they want to know what percent scored over here. So we do the same thing. We'll take 100%. Oh, no, I'm sorry. You wouldn't take 50% up to here and just add to it the 34.1%. So 50 plus 34.1% is going to equal 84.1%. Okay. And so what is 84.1% of 120? So that's 120 times 0.841. 120 times 0.841. About 101. So 101 students. Okay. So again, like I said, hopefully you guys are starting to get this. Don't worry about the half standard deviations. I said, if you guys really want to know about them, I'll teach you about them. But for what we've covered so far, we'd have to do a little bit more. Okay. So anyway, I hope this helped. Probably gonna start something new on Monday. So hopefully you guys got this. If you guys don't have any questions, then we're moving on. If you guys do have questions, we can spend another couple days doing this. Okay. So thanks for watching. I'll talk to you later.